Hello! Welcome to today's lesson on asteroids. In this lesson, we will understand the history and formation of asteroids. Then we will analyze the orbits and locations of asteroids. So far, we have explored the basic structure of our solar system, including planets and moons. We can now dive into the fascinating world of asteroids. Asteroids are fascinating objects within our solar system that offer valuable insights into its history and formation. Let's break down this topic into three key areas: size, elliptical orbits, and locations of asteroids. Asteroids are rocky objects that orbit the Sun, much like planets, but they differ in several fundamental ways. Most asteroids are composed of rock and metal, similar to the rocky planets such as Earth, Mars, and Venus. However, unlike the well-rounded shapes of planets, asteroids are irregularly shaped. This irregularity arises because they lack the significant gravity required to mold them into spheres. Asteroids vary greatly in size. Some are merely a few meters across, making them comparable to large boulders. Others can stretch several hundred kilometers in diameter, rivaling the size of small moons. For example, Ceres, the largest asteroid in the asteroid belt, is about 940 kilometers in diameter. Now let's discuss the paths these rocky bodies take around the Sun. Unlike the almost circular orbits of planets, asteroids commonly follow elliptical or oval-shaped orbits. This means that as an asteroid travels around the Sun, its distance from the Sun changes. Sometimes it is closer and other times it is farther away. The amount of elongation of an asteroid's orbit is described by its eccentricity. An orbit with high eccentricity is more elongated, meaning there's a larger difference in distance between the asteroid's closest and farthest points from the Sun. Conversely, an orbit with low eccentricity is closer to a circle. It's essential to understand that the elliptical nature of these orbits can influence interactions between asteroids and other celestial bodies. Asteroids are not randomly distributed throughout the solar system. They are found in specific regions. The most notable region where asteroids are concentrated is the main asteroid belt. This area lies between the orbits of Mars and Jupiter. Here, millions of rocky objects of various sizes orbit the Sun. The gravitational influence of Jupiter plays a crucial role in keeping these objects confined to the belt. Most asteroids in this belt follow relatively stable orbits. However, occasional collisions do happen, sometimes sending fragments hurtling into different parts of the solar system. Another significant group of asteroids is the near-Earth asteroids. These are asteroids whose orbits bring them close to Earth's orbit. Because of their proximity, some NEAs pose potential impact threats to Earth. This risk has led scientists to closely monitor and track these asteroids to devise strategies for planetary defense. Understanding NEAs is crucial for predicting and preventing possible future collisions with our planet. In today's lesson, we delved into the fascinating world of asteroids. We learned that asteroids are irregularly shaped rocky objects that orbit the Sun, varying greatly in size from a few meters to several hundred kilometers in diameter. We discussed their composition, noting that most are made of rock and metal, similar to the rocky planets. We also explored the elliptical orbits of asteroids, highlighting that their paths around the Sun are oval-shaped with varying degrees of elongation, known as eccentricity. Finally, we identified the main regions of the solar system where asteroids are found, mainly the main asteroid belt, located between Mars and Jupiter, and the clusters of near-Earth asteroids, NEAs, close to Earth's orbit. In summary, understanding the size, orbits, and locations of asteroids helps us gain deeper insights into the dynamic and diverse nature of our solar system. Watch the rest of the GCSE physics course at Sophos Education.